Hello everyone and welcome back. In this video we're going to talk about the relationship between confidence intervals and hypothesis tests. This is something we've already discussed when we introduced the confidence intervals and hypothesis tests for proportions. Recall that these methods are just two different ways of looking at the same set of data. A hypothesis test starts with a proposed parameter and asks if the data are consistent with that value, where a confidence interval starts with the data and finds an interval of plausible values for that parameter. A 1 minus alpha confidence interval will contain all of the null hypothesis values that we would not reject using a two-sided hypothesis test at the alpha significance level. So for example, a 95% confidence interval will contain all of the null hypothesis values that we cannot reject when we perform a two-sided test at the 5% significance level. Let's take a look at an example. Suppose we have a sample of 32 randomly selected years and a 90% confidence interval for the mean annual precipitation in one city is 119.1 centimeters to 125.9 centimeters. So let's first determine the sample mean. So recall that the confidence interval is constructed by taking the sample mean and then adding and subtracting a margin of error. So the confidence interval that we have is from 119.1 centimeters to 125.9 centimeters. So to determine the sample mean, we can take the midpoint of these two values. So 119.1 centimeters plus 125.9 centimeters all over 2 gives us 122.5 centimeters. And so the sample mean is 122.5. So now let's determine the margin of error. So there's a few ways to go about finding the margin of error. We know that the sample mean is 122.5, and the extent of one side of the interval from the sample mean is a margin of error. So we can find the distance between one endpoint to the sample mean. And so the margin of error is 125.9 minus 122.5. And this will give us 3.4 centimeters. Alternatively, we can also take 122.5 and subtract 119.1 centimeters. Now let's suppose that we wanted to test whether the true mean annual precipitation is different from 120 centimeters at the 10% significance level given the same set of data. So what is the conclusion of the test? So let's first write the hypotheses for this test. We're testing whether the true mean annual precipitation is 120 centimeters. And we're looking for any difference. So the alternative would be that mu does not equal 120. Now the 90% confidence interval is 119.1 to 125.9. So we can already conclude the outcome of the test based on the 90% confidence interval. So since 120 falls within the confidence interval, then we cannot conclude that the mean annual precipitation is different from 120 centimeters. And so without calculating the test statistic or the p-value, we can already conclude that we will fail to reject the null hypothesis. And that's because the confidence interval gives us possible values for the population parameter. And since 120 falls within the confidence interval, then the true population parameter could be 120. So we don't have enough evidence to conclude that it's different from 120. And that concludes our lesson for this video. In the next video, we will talk about comparing two population means using the 2-sample t-interval and 2-sample t-test. And I'll see you then.